In the wisp-thin sky of Jupiter's moon Ganymede, the largest satellite in the solar system, astronomers have for the first time detected evidence of water vapor, a new study finds. The discovery could shed light on similar watery atmospheres that may envelop other icy bodies in the solar system and beyond, researchers said. Previous research suggested that Ganymede, which is larger than Mercury and Pluto, and only slightly smaller than Mars, may contain more water than all of Earth's oceans combined. However, the Jovian moon is so cold that water on its surface is frozen solid. Any liquid water Ganymede possesses would lurk about 100 miles, 160 kilometers below its crust. Prior work suggested that ice on Ganymede's surface could turn from a solid directly to a gas, skipping a liquid form, so that water vapor could form part of the giant moon's thin atmosphere. However, evidence of this water has proved elusive, until now. In the new study, researchers analyzed old and new data of Ganymede from NASA's Hubble Space Telescope. In 1998, Hubble captured the first ultraviolet images of Ganymede, including pictures of its auroras, the giant moon's versions of Earth's northern and southern lights. Colorful ribbons of electrified gas within these auroras helped provide evidence that Ganymede has a weak magnetic field.
Ultraviolet signals detected in these auroral bands suggested the presence of oxygen molecules, each made of 2 oxygen atoms, which are produced when charged particles erode Ganymede's icy surface. Previous research suggested these discrepancies were linked to signals from atomic oxygen, that is, single atoms of oxygen. As part of a large observing program to support NASA's Juno mission to Jupiter, researchers sought to measure the amount of atomic oxygen in Ganymede's atmosphere using Hubble. Unexpectedly, they discovered there is hardly any atomic oxygen there, suggesting there must be another explanation for the earlier ultraviolet signals.
The scientists focused on how the surface temperature of Ganymede varies strongly throughout the day, with highs of about -190 degrees Fahrenheit, -123 degrees Celsius, at noon at the equator and lows of about -315 degrees Fahrenheit, 193 degrees Celsius, at night. At the hottest spots on Ganymede, ice may become sufficiently warm enough to convert directly into vapor. They noted that differences seen between a number of ultraviolet images from Ganymede closely match where one would expect water in the moon's atmosphere based on its climate. Water vapor in the atmosphere matches the data very well, a planetary scientist at the KTH Royal Institute of Technology in Stockholm said. The main reason previous research failed to detect water in Ganymede's atmosphere is because the ultraviolet signal from molecular oxygen is very strong. Within this stronger oxygen signal, it's hard to find other signals, Roth said.
Water vapor in the atmosphere matches the data very well, a planetary scientist at the KTH Royal Institute of Technology in Stockholm said. The main reason previous research failed to detect water in Ganymede's atmosphere is because the ultraviolet signal from molecular oxygen is very strong. Within this stronger oxygen signal, it's hard to find other signals, Roth said.
These findings suggest that water vapor actually exists in the atmospheres of icy bodies in the outer solar system, Roth said. Now we might see it more places.